All right, hello everybody. This is Miss Pi, our very last unit for the school year. Super excited about this unit. This is by far my favorite one. Lots and lots of fun with conics. We'll get into what conics are in a little bit, but just for this video, we're just going to go over how to graph a circle with parametric functions. Okay, and all through last unit, I know we covered parametric functions all last unit, and you're probably saying, why do I still have to worry about parametric functions? Well, all through last unit, your time value and your t value in the parametric function was your time. Well, what if you do something crazy and instead of having your t value to be time, what if you decided to have your t value be an angle? Now remember when we did sine and cosine for the projectile motion. Okay, so basically that same kind of thing, but now our t value is going to be our angle instead of our time. Okay, so if you just graph that in a calculator, what do you think it's going to look like? You'll be really amazed. So for this problem number one, whoops, ow, that really hurt my ear. Sorry. Let me see, how do I delete this? There we go. So if you graph this, let's say you set up your window with all these parameters and you just graphed t times cosine, and this time your theta is, 2 times cosine, and your theta is t, not putting t on the outside of the little box, but inside, and then 2 times sine t. Well, if you graph that, you get this really cool circle, okay? And the cool thing about this circle is that the very center is at your origin, and your radius is 2 units, okay? That's a little tiny 2 there. So from the center of the circle to the edge, anywhere along this circle is just the unit of measurement is going to be a 2. Pretty cool, right? Well, what happens, oh, and notice you have a 2 here and here, okay? So that's why your radius is a 2. So what's going to happen if you change that radius to a 5? Well, you get a bigger circle, okay? So again, the center of your circle is at 0, 0, and the distance from here to here is now going to be 5. I'm really hoping you guys are filling out the notes for this and drawing these graphs or these circles on your paper. I will tell you, I want you to be as precise as you can. It'll help if you start at the center and count down 5, do a little dot, count down 5 this way, do a little dot, this way, do a little dot, and this way, do a little dot, and then just kind of get a rough shape, okay? I definitely want your 5 axi intersections dotted, and then just draw your circle as best as you can. I'm not going to be super picky, but you definitely want to have the right units here. Okay, so because whatever we're multiplying by was 5, we're going to have a circle that looks like that, so it's a little bit bigger. Now for problem number 3, your your radius is going to be 8, so an even bigger circle. So from here to the edge is 8 tick marks. Okay, go ahead and draw those in and then move on. Okay, all right, so number 4, notice that now we're for the x value, we're actually adding 5 units to it. Okay, what does that do? Okay, remember all problems 1, 2, and 3, the center of our circle was at the origin. Well, now 1, 2, 3, 4, 5, the center of your circle is now going to be at 5, 0. Okay, and then 1, 2, 3, 4, the radius is still 4. Okay, so notice the 4 from here and here, that is just giving you the radius of your circle. This 5 is telling you to shift the circle 5 units to the right. Okay, for number 5, we're 5 units to the right, but we also have a 3 in the y formula. So what do you think it's going to do? Bam, there you go. So the center of your circle, you go 1, 2, 3, 4, 5 units this way, and then 3 units down. So 1, 2, 3 units down. So when you guys are trying to graph this on your paper, find the center of the circle. It should be at coordinates 5 and -3. And then from that center, count out 4 tick marks because the radius is still going to be 4. Okay, so what do you think will happen if you have a -6 here and a 2 here? Think about it and then look at the graph. Okay, so -6 tells you that the center of your circle is going to go 6 units to the left, and then the +2 is 2 units up. So there's the center of the circle. Again, your radius is 4. Okay, so plot. When you're trying to draw these graphs, you find the center of your circle and then go out however many tick marks you need to go. In this case, you need to go fit 4 tick marks out. All right, so what does this tell you about how to create or how to draw a graph from parametric equations? So you have an H, a K, and A's here. Okay, so in this form, what does the A represent? Hopefully you figured out the A was the length of the radius. Okay, what does the H and the K tell about the circle? Those are the coordinates for the center of your circle. Okay, center is at H and K. And then for problem number 9 in your notes, it said label these constants. So numbers on the graph, well, they're variables, but they're going to be, when you're graphing it, they're values. Anyway, sorry. So the center is just H and K, and the radius is whatever you're multiplying by your A value, okay? So what happens if you have a circle but you don't have a formula? How can you create the formula? Well, my x value here is -4, so I'm going to add -4 to the equation. My y value here is 3, so I'm going to add 3 to the equation. And then I'm just going to count the tick marks. So 1, 2, 3, 4, 5. And maybe I'm not sure, it's kind of hard to see the line, so I want to count this way too. 1, 2, 3, 4, 5. So both sides, both sides have a radius of 5, so I'm going to guess it's 5 times cosine t and 5 times sine t there. Okay? All right, see if you can do this one on your own. Go ahead and pause the video, try it on your own, and then push play again. All right, so we're moving the center of the circle to the right 3 and down 3. So my x is going to be -3, or sorry, my x is a +3, my y is a -3, and then let's count the tick marks, 1, 2, 3 units up, 1, 2, 3 units that way. So I'm multiplying both sine and cosine by 3, and again, t is my angle. All right, last one, you're probably already done with it. You have a -2 and a -1. Guys, this is so easy to figure out what the equations are when you have the coordinate points plotted for you. Super easy. Those of you, particularly if it's really hard to see the grid lines here, in fact, on your paper, it's probably, you can't hardly see it at all. But because I know that my center is at -2 and my edge is at 5, I can just say, okay, the distance from -2 and 5, so this distance here, whoops, sorry, I'm looking for the distance from 2 to 5. So this distance is a 2, and yes, I know that it's a negative, but with distances you don't have negative numbers, it's just absolute values. And then this distance is a 5. Well, if you do 2 plus 5, what do you get? You get 7, okay? So if your grid lines are really, really hard to see, as long as you have the coordinates, you can still figure out the distance, or you can still figure out what your A value is. All right, let me see. I think that's the end of the video. Yep, we'll start on this tomorrow, or on Tuesday. We're going to start on all the different types of conics, and we're going to have some fun with Play-Doh. Well, those of you that watch the video and fill out the notes get to play with Play-Doh tomorrow in class. So I hope you watch this video before class time. All right, bye.